Hello everyone. Today I challenge myself to present a lecture on projectile motion. I hope this video makes you well. Now, ready to explore the fascinating world of projectile motion. In our previous lessons, we have explored motions in one dimension, including uniform linear motion, uniformly accelerated linear motion, and free fall. Today's lessons will focus on the motion in two dimensions, specifically projectile motion. This involves the motion of an object in a two-dimensional space under the influence of only gravity. First and foremost, we need to grasp an essential principle that any motion in two dimensions can be considered as a combination of two independent one-dimensional motions in two perpendicular directions with equal time intervals. In the case of a projectile motion, we can analyze the motion of the object as motion in the horizontal axis, x-axis, and motion in the vertical axis, y-axis. The initial velocity of the projectile motion in the x and y axis is v naught x equals v naught cosine theta and v naught y equals v naught sine theta, respectively. In the x-axis, the acceleration of the projectile motion is zero, so the object moves with a constant velocity. The equation for the coordinate and velocity of the projectile motion in the x-axis are x equals s naught plus v naught st, and vs equals v naught s equals v naught cosine theta. In the y-axis, with the positive direction upward, the acceleration of the projectile motion is the acceleration due to gravity g. Consequently, the object experiences uniformly accelerated linear motion in the vertical axis, or we have acceleration ay equals minus g. The equation for the coordinate and velocity of the projectile motion in the y-axis are y equals y naught plus v naught y t minus 1/2 t squared. Vy equals v naught y minus gt, and vy squared minus v naught y squared equals minus 2g y minus y naught. So we have a system of 5 equations. Assume that the projectile motion is launched from the origins in which x naught equals 0 and y naught equals 0 2. Solve for t from equation 1 and substitute it into equation 3. We have y equals v naught tan theta x minus 1/2 g over v naught square cosine theta square s square. We can see that this equation presents an inverted parabola, or we can say that the trajectory of a projectile motion is an inverted parabola. To find the maximum height that the projectile motion creates on its trajectory, we can use equation 5 with the observation that at that point Vy equals 0 and y equals s maximum. We have s maximum is equal to v naught y squared over 2g. And to determine the horizontal distance covered by the projectile motion, first we use equation 3 with y representing the final height to find the time of flight t. And then we substitute the value of t into equation 1 to find the horizontal distance s. And you should pay your attention to the symmetry of the trajectory to determine whether t is before or after the time in which the object reaches its maximum height. So, thanks for your attention in my challenges. Thank you and goodbye.